Okay, let's dive into this. We're going to explore a really powerful workflow for building AI agents that don't just fix their mistakes, but actually learn from them permanently.
So let's start with a feeling that, if you're a developer, you know all too well. You build an AI agent, it messes up, and what do? You tweak the prompt, maybe add a little magic spell like "please don't hallucinate," and then you just cross your fingers and hope for the best. It's this frustrating cycle of trying to fix things based on vibes, not solid engineering.
And look, it's not like we don't have the tools to fix this. Major frameworks like LangChain have raised a ton of money, we're talking huge sums here, to solve this exact problem. They've given us all these sophisticated platforms for testing and evaluation, so all the individual pieces are definitely there. But here's the crucial point. Having all the right tools isn't the same thing as having a repeatable, solid workflow. You know, a process that guarantees when you fix a bug, that bug stays fixed forever. It's kind of like having a gym membership but no workout plan. You've got the equipment, but no strategy.
And that brings us to the real heart of the problem with building reliable AI agents today. And it's actually a bit more subtle than you might think.
So when an agent messes up, what's really going on under the hood? Is it just getting an answer wrong, or is the failure happening at a much deeper level?
And this is the big insight right here. The agent isn't just getting the facts wrong. The real issue is that it's using the wrong kind of thinking for the job it's trying to do. It's trying to do work that needs absolute precision in a space that's really designed for judgment and creativity.
This lays it out perfectly. On the one hand, you have the latent space. This is where the AI does its fuzzy reasoning, its judgment calls. It's great for things like interpretation. On the other hand, you have the deterministic space. This is for pure precision, for rules. Tasks where there's only one right answer, like running a piece of code. The bug, the real bug, happens when the agent tries to solve a deterministic problem while staying in that fuzzy, latent space.
Okay, so let's make this real. Let's see how this whole distinction actually plays out by looking at a couple of real-world failures. So, failure number 1. An agent gets asked about a trip from 10 years ago. What does it do? It spends 5 whole minutes trying to hit live APIs, doing all these complex searches, and it fails. The really frustrating part? The answer was sitting in a local file the entire time. All it needed was one simple search. It used its creative, latent brain for a simple, deterministic lookup job. So the fix here wasn't just, tweaking a prompt. No, it was a permanent structural rule called a skill. This skill basically forces the agent to follow a super simple, deterministic process. If the event is in the past, you always check the local knowledge base first. No exceptions. It takes the guesswork right out of it.
And the second failure? It's eerily similar. The agent says a meeting is in 28 minutes, but in reality, it's 88 minutes away. It was off by exactly 1 hour. Why? Because it tried to do the UTC to Pacific time zone conversion in its head, and it just got it wrong. It tried to reason its way through a simple calculation that a script could have done perfectly in an instant.
And you guessed it, the solution is another hard and fast rule, another skill. It basically tells the agent, hey, never do time-sensitive math in your head, ever. Run this script instead. It forces a task that needs precision into the space that's built for precision.
So we've got 2 totally different failures, right? A calendar lookup and time zone math. But they share the exact same underlying problem and, more importantly, the same kind of solution.
And this is where it gets really cool. It reveals this powerful feedback loop. The agent uses its flexible, latent intelligence to spot a problem. Then it uses that intelligence to build a rigid, deterministic tool, like a script, to solve it. And here's the kicker. That new tool now becomes a permanent constraint on the agent. It makes that specific type of mistake impossible to make again. That old failure path, it's now structurally blocked off forever.
Okay, so that's the theory. It's a powerful idea. But how do you actually turn this from a clever concept into a rigorous, repeatable engineering practice that your team can use every single day? Well, that's where the Skillify checklist comes in.
To really turn this process into a habit, to make sure that every single fix is permanent and robust, the author came up with a super comprehensive checklist.
And here it is, the 10-step Skillify checklist. I mean, this thing is a full quality gate for any new capability. It covers the whole shebang, from writing the skill's official contract and the actual code, to running a whole suite of tests, unit tests, integration tests, LLM evals, even end-to-end smoke tests. Every new skill has to pass this entire process before it gets the green light.
Now I want to call out one step in particular, number 6, the resolver trigger. This is so crucial. It's basically the routing rule that tells the agent, hey, when you see this kind of problem, you need to use this specific skill. The analogy here is perfect. Without it, it's like having a world-class surgeon on staff at a hospital, but forgetting to list them in the directory. Nobody knows they're there to help.
And this isn't just a theoretical problem. A real audit of an agent found that 15% of its skills were completely dark. They existed, the code was there, but they were totally unreachable because they weren't registered properly. The agent literally didn't even know it had these superpowers.
So let's zoom out. What's the big takeaway from all of this? Why does this matter for anyone who's trying to build something real with AI today?
It really comes down to this. We need to bring the same hard-won discipline we have in traditional software engineering over to the AI world. You know, in a good software team, you don't just fix a bug and move on. You write a test to make absolutely sure that exact bug can never, ever happen again.
And when you follow this kind of process, you create a system where the agent's judgment doesn't just get a little better for one conversation. No, it improves permanently. Every single mistake becomes a lesson that is literally baked into its structure, shaping its behavior forever.
And that really leaves us with a powerful thought to chew on. What new possibilities open up when our AI partners don't just recover from failure, but are structurally, fundamentally guaranteed to grow from it every single time?